before the invention of the PLC. Industrial automation relied on complex, bulky, and expensive relay-based control systems. But how do we go from these mechanical systems to the powerful PLCs we use today? Let's take a journey through history to understand the evolution of PLCs. 1940s to 1950s factories, relay logic panels, electromechanical control systems. In the early days of automation, industries relied on relay-based control systems. These systems used thousands of relays and mechanical switches to control machines and processes. See the factories of 1800s.
In the late 1700s, most people worked in the fields, on land they did not own. Those who owned the land, called aristocrats, lived refined lives in elegant manor houses. Servants raised their children and did their housework. The landowners and the people who worked for them depended upon each other. It was a system that had existed for centuries. In towns across England and the United States, a series of extraordinary innovations would alter the way people lived and worked for the next 150 years. Inventors had found new ways to harness nature's energy. They built new kinds of machines, powered by water, steam, and coal. The new machines replaced hand-powered tools. They did the same work, only cheaper and faster. Much of the work was done outside the home, in specially designed buildings, the first factories. Mechanization began in the textile mills of England, where one machine attached to a spinning wheel could do the work of 50 people. Fuel, clothing, and food all became more affordable. With the development of locomotives and steamboats, manufactured goods could now be sold halfway around the world. Families moved from the villages of their ancestors to new industrial towns. And a new class of people emerged, workers who produced goods. Industrialists, the people who owned the factories, employed hundreds, sometimes thousands of people. And they made enormous profits in their industrial centers. But while the Industrial Revolution brought wealth to some and jobs for others, it came with a price tag. Pollution from coal-powered factories turned the cities black. Lack of housing created the first urban slums. And the demand for more and more goods and higher profits brought the exploitation of workers, including children. Some of the worst conditions were seen in the textile mills of New England. In the 1830s, a 10-year-old mill girl described her life.
We were paid $2 a week, and the working hours of all the girls extended from 5 o'clock in the morning till 7 in the evening, with 1.5 hour for breakfast and for dinner.
It was the hiring of children, some as young as 5 years old, throughout the 1800s and early 1900s, that outraged the public. Workers and reformers protested. They formed unions and associations and fought for government regulations to limit the workday and protect children. These laws helped address many of the abuses brought on by the Industrial Revolution. Today, we are in the middle of another revolution, a technological revolution. We live in what's called the global village, because we can connect with people around the world as if they lived next door. And we can now work anytime and anywhere. We will have to wait and see where this new revolution leads.
But there was a big problem. Complex wiring. Each function required extensive wiring. Slow modification. If a change was needed, engineers had to manually rewire the whole system. High maintenance. Relays wore out quickly, causing frequent failures. As industries expanded, the limitations of relay logic became a bottleneck. There was an urgent need for a smarter, more flexible solution. Chapter 2. The birth of the PLC, 1968. In 1968, a revolutionary idea was born. The first ever programmable logic controller, PLC, was developed by a team led by Richard Morley at Bedford Associates. It was called the Modicon 084 and was designed to replace hardwired relay systems. Why was PLC was game changer? Reprogrammable. Engineers could modify logic without rewiring. Compact and reliable. Replace thousands of relays with a small, durable system. Faster operations. Reduce downtime and increase efficiency. Chapter 3. The Evolution of PLCs, 1970s to today. 1970s. The rise of PLCs. PLCs becoming more common in factories. Siemens and Allen Bradley early models. Microprocessors made PLCs more powerful. Companies like Siemens, Allen Bradley, and Omron entered the market. PLCs started using ladder logic, making them easy for electricians to understand. 1980s, the era of communication and standardization. Communication protocols like Modbus and Profibus. PLCs started communicating with SCADA systems for centralized monitoring. Memory capacity and processing speeds improved. 1990s, advanced features and networking. PLCs became more compact and powerful. Introduction of human-machine interfaces, HMIs, for better user interaction. Ethernet-based PLC communication replaced older serial systems. 2000 to present smart and IoT-enabled PLCs. Integration with IoT and AI for smart automation. Cloud-based PLCs allow remote monitoring and control. Cybersecurity improvements to protect industrial networks.